Okay, we'll start in a minute. Okay, so um, some announcements. So one announcement is about the test scores are on LMS. You should be able to see those. A few students have asked whether the mean and standard deviation is available. We have not calculated that, but when I shared the scores of individual students, I checked that box which said that statistics should be shared with the students. So I'm not sure if those are shared with you or not. Was anyone able to see the mean or the statistics or histogram of the test scores? Okay, people are getting an error. So I don't know. Maybe LMS is misbehaving. We have a pretty old version. Uh, you know, that's okay. So Noman says that LMS has a bug. When we open the statistics, it crashes. Uh, that's okay. No worries. We will when we calculate the scores, means, and standard deviation. We will let you know. Somebody had raised a hand. Bilal. Bilal, you had a question.
मैंने वही बोला था जो नुमान ने बात कर दी थी. मैंने वर्बली बोलना तो उसने लिख लिया.
Great. Thank you very much. Okay. So test one scores and as you know, these questions on the test, they use data which was slightly randomized for the students. So we could not provide answer to all the randomized values, but sample answers to all the questions are also on LMS. You can take a look at those. Okay. The TAs are telling me that a few students, actually several students, have asked question about that engineering department question, and I will very quickly go over that. And that engineering department question was that I'm not sure which question was this. This was the question about students in a department. So let's say you have 800 students in a department, and you were given, everyone was given, but this number might have been different for every student, but you were given that there are so many students in a department, and let's say 30% are taking maths, and let's say 40% are taking applied probability or probability. Yeah, whatever. Um, so the number of students taking maths, how many students are taking maths? Please, no answer to that. 30% of 800 is 240, and 40% of 800 is 320. So this is the number of students who are enrolled in maths class, and 320 is the number of students who are enrolled in AP's class. Okay. Now, there were two questions. One question was, what is the max possible number? Max possible number. By the way, we don't know which students are taking the math class, which students are taking the applied probability class. It is entirely possible. It is entirely possible that the students who are taking the math class, all of these 240 students are also enrolled in applied probability, and then another 80 students are enrolled in applied probability. It is also possible that these 240 students who are taking the math class, none of them are taking the applied probability class. And then applied probability class is taken by these 40% other students, 320 other students. Okay. So part A asked, what is the maximum possible number of students who are taking both maths. Noman, please mute your microphone, Noman. So both maths and applied probability. People who are taking both maths and applied probability. So you can see that there is a number of students who are taking the maths class. There is a number of students who are taking the applied probability class. Part A is asking the maximum possible number which are taking both courses simultaneously. So if I draw the Venn diagram like this, people who are taking the maths class and people who are taking the applied probability class, which means a different 320 people taking the applied probability class. What is the common area here? Nobody is taking both the class together. There is no student who is taking both the courses. No student. So this will give us the answer as 0, but this is not the maximum possible number. The maximum possible number will come up when we have these 240 students. They are all included in these 320 students. So these 240 students here are included in the 320 students, which means that 240 students are taking both the courses, and then there is another 80 students who are taking just the applied probability course. So this answer would be 240. Would be 240. Part B was asking, what is the max possible number? Max possible number who are taking at least one of the course, who are taking at least one of the courses. So since the question is asking for the maximum possible number, so if I consider this figure here, which I have already drawn, these 240 who are taking the maths course, they are included in the 320 students who are also taking the applied probability course. Now, if I consider this Venn diagram, then this number who are taking at least one of the courses will be 320, but that's not the max possible answer. That's not the maximum possible answer. To find the max possible answer, I will need to consider this Venn diagram, that math students and applied probability students, they are completely different sets. And now the max possible number of students who are taking either maths or applied probability is just the sum of these two. So it's 240 plus 320. Whatever that number comes out to be, 560. Okay. So the students who had the questions about this, should you can go back and look at the solution as well. But hopefully this explains it. Now, what I'm going to also do is, we had a question about partitions and Bayes theorem in the test, and I'm going to give you one very quick example of Bayes theorem and partitions. One simple example which will cover both partitions as well as the Bayes theorem. Okay. Now, does somebody has a question?
सर मेरा एक सवाल था. सर वो बस क्वेश्चन 3 का मैंने बस जल्दी से एक चीज कंफर्म करानी थी कि वो उसमें पूछा था कि 3 कोर्सेज हैं और 3 बच्चे ले रहे हैं, तो प्रोबेबिलिटी ऑफ टेकिंग 3 of them taking one course, is that just 1/3 into 1/3 into 1/3?
That's not 1/3 into 1/3 into 1/3. Okay, ये
जी सर.
आप अलग से पूछ रहे हैं, you know, but really the first TA आप शायद उस वाले क्वेश्चन की बात करें. The first TA can apply for any of the courses. पहला स्टूडेंट, पहला जो TA है वो किसी भी कोर्स के लिए अप्लाई कर सकता है. We need to make sure that the second guy and the third guy, they apply for the same course. I have given a detailed solution. Please take a look at that. या ऑफिस आवर्स में पूछ लें, पियाजा पे पोस्ट कर दें अगर नहीं पीस का पता चलता.
ठीक है, थैंक यू सर.
Okay. So I'm going to give you example of Bayes theorem one more time, and for this I will use this example of two urns or boxes. So this is urn 1 and this is urn 2. Okay. I hope the screen is visible to everyone, right? Yes. Yeah. Okay. So you have urn 1 and urn 2. Urn 1 has 3 black balls and 6 red balls. Urn 2 has 4 red balls and 5 black balls. Lots of time, this is a very simple question, but a lots of time you will have questions that you will need to model, by using either partitions or Bayes theorem or some other mechanism. No, but the statement of the problem, after some experience, you will be able to find out. You will be able to find out if you can apply the partitions model or Bayes theorem model. So in this case, I will give you this example that you have urn 1 and urn 2, and you pick one of the urns at random. Pick one urn at random. When I say at random, which means you can pick urn 1 with probability 1/2 and urn 2 with probability 1/2. So with probability 1/2, you will pick urn 1, and with probability 1/2, you might pick urn 2. Okay. Now, if you pick urn 1, then after you pick the urn which has been randomly selected, then you draw a ball which could either be red or black. So if you pick urn 1, then what is the probability that you will pick a red ball? What is that probability? Very quickly in the chat window. What is the probability that you will get a red ball if you pick urn 1? Noman, please don't send private messages. I will not be able to answer that in the class. There are 150 students, so either raise your hand and ask a question, or post it on Piazza or ask during the office hours. So what is the probability? Red ball, 3 out of 9, 6 out of 9. Sorry, 6 out of 9. So this would be 6 out of 9. 6 out of 9. Okay. And what would be the probability of a black ball? This would be 3 out of 9. Notice that the probability of red ball, picking a red ball or a black ball after you have selected urn 1, this should sum up to 1. This should sum up to 1. If you had 4 colored balls, red, blue, green, and black, then the probability of picking each of those balls, all of those should sum up to 1. So just like here, 6/9 and 3/9, they add up to 1. Okay? If you pick urn 2, then what is the probability of getting a red? If you pick urn 2, what is the probability of getting the red? So this would be 4 out of 9, and probability of getting a black is 5 out of 9. Okay. Everyone is okay with that? Yes? So Naman, you have a question? Please go ahead and ask.
सर मेरा ये क्वेश्चन है जो लास्ट टाइम अभी आपने समझाया है, प्रोबेबिलिटी वो जो मैथ और इंजीनियरिंग स्टूडेंट्स वाला, सर ये कैसे मतलब आप कह सकते हैं कि जो 50% मैथ है या 30% जो प्रोबेबिलिटी उठाई है उन्होंने मैथ भी उठाया है, इवन तो आपने क्वेश्चन में जब क्लियर है कि 50% ने मैथ उठाया है और 30% ने प्रोबेबिलिटी उठाई है।
देयर इज नो 50% और 30%। आप ये ऑफिस आवर्स में पूछ लें, क्योंकि एक हमने 30% बताया, एक 40% बताया। मुझे नहीं पता आप 50% का आ गए।
जी मैं ऑफिसर में पूछूंगा आपका क्वेश्चन।
हाँ हाँ, so if you can, yeah. So now let me ask two questions here. First question is related to partitions. First question, or law of total probability. First question is related to that. And the question could be, what is the probability that you will pick a red ball after you have selected a random box? Now, since you don't know which box was chosen, you cannot answer this question unless I tell you which box was chosen. Okay. However, if I tell you that box 1 was chosen or urn 1 was chosen, then the probability of red would be the conditional probability that urn 1 was chosen. So see, there are two parts of the experiments here. The first part of the experiment is choosing an urn randomly, and the second part of the experiment is choosing a ball, which could be red or black in the second step. So I'm asking you, what is the probability of this red ball? So red ball can come either from urn 1 or from urn 2. But I'm not going to tell you whether it was urn 1 or urn 2, because if I tell you if it was urn 1, then it would not be the probability of red. It would be the conditional probability of red given urn 1. So now, if I'm interested in finding the probability of red, then this should be probability of red given urn 1 was chosen into the probability the urn 1 was chosen plus. So this is the probability that you pick the red and urn 1. Now, the other thing that you want to add here is the probability of red and urn 2. So this is this is exactly the same as the partitions example that we did last time as well. So what is the probability of red and urn 2? Red and urn 1, red and urn 2. Red and urn 2 is probability of red given urn 2 into probability of urn 2. Okay. So, and you can calculate this probability. This would turn out to be the probability of red given urn 1. Probability of red given urn 1 is 6/9. Probability of urn 1 is 1/2, plus the probability of red given urn 2 is 4/9 into 1/2. So this would be 5/9. 5/9. Everyone is okay with that? Yes? Verbal feedback? Does anyone have a question? So maybe people are okay with that. At least 3 people, 4 people are okay with that. If you have a question, please raise your hand if you are not comfortable with computing this probability of red. The reason that we have broken it down into 2 is because we don't know which urn will be selected in the first part of the experiment. So you can also see it in the form of Venn diagram that we drew last time, that one is for urn 1, the other is for urn 2. So this is the probability of red ball. This circle is the probability of red ball. So you can see that this is the probability of red ball and urn 1, and this is the probability of red ball and urn 2. So these two areas, this one is here and here. In fact, I should use this red color for this. So this red guy is here, and This blue guy is here. Okay. Now, now I'm going to ask a question which would be answered by Bayes rule, and you should realize when should we apply Bayes rule or Bayes theorem. Okay? Now I'm going to ask you this question: that I picked a urn at random, pick an urn at random, and picked a ball from that randomly chosen urn. Okay, so pick an urn at random and pick a ball from that urn. When I say that urn, I'm not going to tell you whether it was 1 or 2. It could be either one. Pick a ball from that urn. The ball turns out to be red. Turns out to be red. Find the probability that urn 1 was chosen. So once again, realize that what I'm telling you here is कि आपके पास ये red वाली आ गई है, and red can be obtained by two paths. Either urn 1 was chosen or urn 2 was chosen. Now, if I give you that red was chosen, red ball was chosen, now I am asking you the reverse question: what is the probability that it came from urn 1? What is the probability that urn 1 was chosen, given that you have picked a red ball? Everyone is okay with this guy here, this conditional probability here, that this question here is asking us, to compute this probability, Everyone is okay with that? We don't know yet how to calculate that. We will quickly. Okay. Now, in order to answer this question, I will do some side calculation. Remember, we defined the conditional probability of A given B is equal to probability of A and B divided by probability of B. Everyone is okay with that? Yes? Yes or no? This is how we define the conditional probability. Now, another expression that I will define is going to be probability of B given A. Probability of B given A is also equal to probability of A and B, or B and A. B and A and A and B are the same, divided by probability of A. Everyone is okay with this as well? Yes. Okay. Now, you notice that you have a probability of A given B here and a probability of A given B here, which means that I can write, by comparing these two, I can write probability of A given B into probability of B. This guy here, which is probability of AB, is equal to probability of B given A into probability of A. Everyone is comfortable with that? I will also tell you what this means. This means that probability of some event conditioned on another multiplied by this probability is equal to probability of this second event condition. देखिए the conditioning अब उलट हो गई है. यहाँ पे A given B था, यहाँ पे B given A हो गया. Now, why do we do that? Where do we make use of this? We make use of this in Bayes theorem because probability of U1 given R, probability of urn 1 given R, we are asking you, okay, what is the probability of urn 1 given you have picked a red ball, which could be from here or from here. Okay, what is the probability of urn 1? This is difficult to calculate. However, if I tell you that urn 1 was selected, then the probability of R becomes very easy. We already calculated that. Probability of R given U1 is easy to calculate. So what I'm going to do here is I'm going to convert this into probability of U1 given R is equal to probability R given U1. R given U1 into the probability of U1 divided by probability of R. ये एक्सप्रेशन कहां से आ गई? ये एक्सप्रेशन जो है ये यहां से आएगी. Probability of A given B is equal to probability of B given A. ये probability of A से multiply होती है, probability of B से multiply होती है. Okay, so if you rearrange this expression, you will see that probability of A given B is equal to probability of B given A into probability of A divided by probability of B. इसको मैं यहाँ नीचे लेके जा सकता हूँ. Okay, so I'm going to erase this now, this entire thing here. Okay, and go back to this expression. So here I'm going to say that this probability of R given U1, this is something that we have already calculated. R given U1, EARN1 was selected. What is the probability of R? EARN1 was selected, this guy was selected. What is the probability of R? You already calculated that, 6 out of 9. So this guy is 6 out of 9 into probability of EARN1, which was only 1/2, divided by probability of R. Now, where does this probability of R comes to? ये हमने पहले ही calculate की है probability of R. It is entirely possible कि आपसे question का part ही ना पूछा जाए, आपसे partitions का पूछा ही ना जाए, and we directly ask you the question which is pertaining to the Bayes rule, then you will still need to calculate this probability of R by doing these partitions, because down here you have to calculate the probability of R, which we already calculated here as 5/9. 5/9. So this turns out to be 3/5. Okay. I can ask all sorts of questions, that what is the probability of U1 given R complement, which means that if red ball was not selected in the second part of the experiment, what is the probability that in the first part of experiment you had EARN1 selected? What this really means that probability of EARN1 was selected given that you had picked the black ball. You had picked the black ball in the second part of the experiment. Okay. Now, this is very, very interesting. You can solve lots of questions by making use of Bayes rule and partitions. So I will give you one more example before we move on. In this case, I will give you example of a criminal or non-criminal. No, somebody might be guilty. Somebody might be guilty with probability 0.6. A randomly chosen individual who is under trial could be guilty. Somebody who is under trial could be guilty with probability 0.6 and could be not guilty with probability 0.4. Once again, realize that this 0.6 and 0.4, they both add up to 1. So not guilty with probability 0.4. If the person is guilty, it will have criminal characteristics. Always. When I say always, that means with probability. Always means with probability. What would be the probability of something which always happens? With probability 1. Okay. Now, this guy will have criminal characteristics with probability 1. And if this guy is guilty, then this guy will not have characteristics with zero probability. यानी अगर वो गिल्टी होगा तो कैरेक्टरिस्टिक्स उसमें लाजमी आएंगी, with zero probability. Okay. Similarly, if this guy is not guilty, if this guy is not guilty, this data is, by the way, given to you, is given to you. We are not calculating anything as yet. Okay. And if this guy is not guilty, then this guy will not have the criminal characteristics, criminal characteristics with probability 0.8. It's given to you. We just gave that data to you. Okay. And if this guy is not guilty, given that this guy is not guilty, then this guy will have the criminal characteristics with probability 0.2, of course, 0.2. Okay. Now, so let's say when we say it's guilty, this is denoted by G, and not guilty is denoted by N. Okay. Will have criminal characteristics maybe with C, and not have the criminal characteristic maybe C complement. You can write any letter, X or Y or Z, whatever you like. Similarly, we'll have characteristics C and C complement. Sometimes people write the complement as this. Sometimes we write it as this. Both are kosher here. Okay. Now, the question here is, what is the probability that the person has criminal characteristics when that guy is guilty? What is the answer here? In the chat window, what is the probability that the person will have criminal characteristics given that this guy is guilty? Great. 1. Okay. What is the probability? This person will have criminal characteristics given that the guy is not guilty? ये diagram से पता चलना चाहिए. Not guilty हो, so what's the chance this guy will have the characteristic of a criminal? Is 0.2. And what is the probability of being guilty, which is also read from the diagram, which is probability of guilty is 0.6. Okay. Now, I am asking you the question. The question is, what is the probability that the person was guilty? You pick a randomly chosen person. Let me just write that down as well. Pick a random person. एक random बंदे को उठा लिया. Pick a random person and found criminal characteristics in that person. Is it always true that this guy will be guilty? Yes or no? Will this guy always be guilty? No, because it is also possible that the guy is not guilty, and still there is some probability, small probability, that this guy will have characteristics. Okay, you found the criminal characteristics in the person. What is the probability that the person is guilty given that you found the criminal characteristics? Now, this is difficult to find. So what we are going to do here is I'm going to write the formula for conditional probability, which is probability of guilty and having characteristics divided by probability of C, which is also written as probability of C given G into probability of G divided by probability of C. Okay. Now, you can either write from this guy to this guy on the right directly, or you can go in steps, one and the same thing, doesn't matter. Okay? So we already know some of the answers here. This guy, C given G, probability of C given G is known to us. So this guy is known to us. Okay? Probability of G is also known to us. Okay? What is the probability of C? The probability of C is computed by partitions. What is the probability of C? You can get a C if you are here, or if you are here. Okay? So you can have a characteristics of criminals from both parts, from both sides. Either you are guilty or not guilty. So probability of C would be, if you are guilty, then with 100% chance you will get the characteristic. And if you are not guilty, which is 0.4, then the chance that you will have the characteristics is 0.2. So this turns out to be 0.68. So then the probability of guilty, given that you have the characteristic, is going to be probability of C given G. C given G is this guy here. C given G is this guy here. C given G is 1. If you are guilty, you will always have characteristic, and the probability of guilty is 0.6 divided by 0.68, which turns out to be 0.882. So not quite 100%. If you have the characteristics, there is a high probability. There is a 88%, 88.2% probability that you will be guilty, but not 100%. Mohsin, you have a question? Please go ahead.
Yes, sir. Sir, there was just this one little confusion. Okay, sir, आपने यहाँ पे probability G given C में you're using two equations. मतलब probability GC were probability criminal and the one at the right. Sir, to me the center one sort of seems very obvious always. मतलब मैं हमेशा ये use करके I just found the answer as well. So I just wanted to confirm one thing, that you always end up using the right one more. I've seen. So is there something I'm missing in that? Like any particular reason for that?
Right one means this guy,
Yes, sir.
and I don't use this guy.
No, you do, but you still do. I mean, a lot of times you do refer to the right one a lot. So just
No,
for my own clarity.
The reason is I will tell you the reason. The reason is, if you can calculate the probability of G and C, you will see that this is exactly the same as the probability of C given G into probability of G, which is 0.6 multiplied by 1 here. So probability of G and C is really this probability. So it's one and the same thing. No different.
ठीक, sir.
Okay.
Just like
So
one little thing. Yeah.
now I'm gonna move on to some more examples of independence. We have talked about Bayes rule, partitions, conditional probability, a little bit more about independence. We defined independence as two events A and B are independent if probability of A and probability of B multiplied together is equal to probability of A and B occurring together. We said that this means that A and B are independent. One does not impact the other. So how is it related with conditional probability? Let's try to write the answer. We know that probability of B given A or A given B, whatever you like to write, is equal to probability of A and B divided by probability of A. Okay. If I rearrange that, then probability of A and B comes out to be, you can take probability of A here, probability of A into probability of B given A. Okay. Now, if you compare equation 2 with equation 1, if A and B are independent, if A and B are independent, if A and B are independent as in expression 1, then the expression 2 will tell you that if A and B are independent, then probability of B should be equal to probability of B given A, which is really the definition of independence, that if you are given A, then it does not matter to B. The probability of B remains exactly the same whether A is given or not given, And by the way, this independence is not one way. It's bidirectional. So if A and B are independent, then probability of A will also equal to probability of A given B, which means if B is given to you, it does not impact the probability of A. Probability of A remains the same whether B is not given or whether B is given. B is not given on the left side, B is given on the right side. So the probability of A does not get impacted whether B occurs or not occurs. Okay. So this is how we relate the conditional probability with independence. Okay. I will have one example here. And this example is going to be 52 cards deck. एक deck आपको दिया हुआ है. Pull one card, okay, and define A as getting an ace. And there are 4 aces. Remember, there are 4 aces in 52 cards. Okay. They also define B as the event getting a spade. And there are 13 spades. 52 आपके पास cards हैं. There are 4 suits. One of them is spades, club, heart, and diamond, and one of them is spades. Okay. So now what is the probability that you pick a card, you pull one card? What is the probability that A occurs? What is the probability of A? In the chat window, probability of A. Some more answers, please. Okay, 4 out of 52. Why? Because 4 aces and 52 cards, 4 out of 52. Probability of B. What is the probability of B? In the chat window, please. 13 out of 52, because there are 32 spade cards out of those 52. Then, and you have this, probability of B as 13 out of 52. What is the probability of A intersection B, or A and B? Which means you get a spade as well as a 4, which means an ace. So which means you get an ace of spades. How many ace of spades are there? There is only one card. Which is an ace as well as a spade. क्योंकि ये जो 4 aces हैं, one ace is for diamond, one is for clubs, one is for hearts, and the 4th one is for spades. So there is only one card which is ace of spades. So this is 1 out of 52. Okay. Now it is probably obvious to you that in this case, probability of A multiplied by probability of B is equal to probability of AB. What that means is A and B are independent. And we are happy with that. So far so good. Now let's tweak something. So before pulling out the card, discard one card from the deck. Discard the Queen of Hearts. उसको मैंने 52 कार्ड से निकाल के फेंक दिया. are A and B independent now? Yes or no? Verbal feedback, no, non-verbal feedback. So non-verbal feedback, yes or no? In the participant window, you have yes and no. Are A and B independent? I have thrown out this card, which is the Queen of Hearts. This is neither an ace nor a spades. Neither an ace nor a spade. ये ना ace है और ना spades है. This is Queen of Hearts. Okay. देखें 52 कार्ड में से आपने एक कार्ड निकाल दिया है. शायद उसका कोई फर्क ना पड़ा हो. अगर पड़ा भी होगा तो बहुत थोड़ा फर्क पड़ा होगा. If it mattered, then it would probably not matter much. But let's try to find out. Let's try to find out. Okay. Left with how many cards? Now I have discarded the Queen of Hearts. Left with 51 cards. Pick one at random. Pick one at random. Pick one at random. The probability of A is equal to how many aces are there? How many aces are there? See, all the 4 aces are there. So this would be 4 out of 51. 4 out of 51. Okay. Thank you everyone who have answered this question. What would be the probability of B? What is the probability of B? What is the probability of B? In the chat window, probability of B, that out of those 51 cards, you will pull one of the spades, which is 13. We still have 13 cards of spades, 13 out of 51, 13 out of 51. Okay. So this is great. So far, so good. What is the probability that you have A and B, which means you pull out a card out of those 51, and this card is a ace of spades. Ace of spades. What is this probability? There is one card which is ace of spades, but now I have a total of 51 cards, not 52 cards. So this would be just like before, this would be 1 out of not 52, but 51 this time. 51 this time. Okay. So this is great. Now let's try to find out if probability of A and B is equal to probability of A multiplied by probability of B. Is this true? Yes or no? So basically what I'm asking is 1 over 51 is equal to, so this would be 52 over 51 into 1 over 51. Are these equal? Are these equal? Well, they are not equal, which means A and B are not independent, which means that they are dependent. Now. This is very interesting that you pulled a card and you threw it away, which was neither an ace nor a spade, but pulling that card out has impacted the probability, has impacted the independence of A and B, impacted the independence of A and B. But you might notice that, you know, this term here on the left is 1 over 51. The one on the right is also 1 over 51, but multiplied with this number, which is very close to 1. This number which is very close to 1. So they are approximately the same. So that means that although A and B are not independent, their dependence is very, very small. The reason that their dependence is very small is because we have thrown away only one card out of those 52 cards. If we had thrown away many cards, then this dependence will keep on increasing. Will keep on increasing. Okay. Now I want to talk about So Hamza has a question, probability of A is equal to 4 over 51. No, it's not 4 over 51. Probability of A is not 4 over 51. Probability of A, this is 4 over 51. What I have done here is basically I have written 4 over 51 multiplied by 13 over 51. Multiplied by 13 over 51. And I multiplied this 13 with a 4, which is this 15. So these two guys are not equal. These two guys are not equal. I can fix this. And the answer would still be the same. Goes here. And this guy comes here. Okay. And okay. So Hamza, was this your question? I hope this answers your question. Bilal, you have a question? Actually, Jawad had a question. Jawad had a question first.
सर यही 52/51 का पूछना था तो वो आपने बता दिया ठीक है
ये clear हो गया ना? हाँ.
जी
Aisha has a question and then Bilal. Yeah, Aisha?
Sir, I wanted to know how did pulling out a card change the independence of A and B? They were dependent before the cards were pulled out, right?
They were not dependent. They were independent
Yeah,
before
and
the
they,
card. And they became dependent when the card was pulled out.
okay.
They were not dependent before. They were independent before. They are dependent now. Okay. Bilal, you have a question?
सर इसकी लॉजिक बता सकेंगे? सेम आयशा वाला क्वेश्चन था मेरा, लेकिन इसकी यानी इंट्यूटिवली लॉजिक क्या बनती है?
हाँ,
कि वो डिपेंडेंस क्रिएट हो जाती है वंस वी चेंज द टोटल्स.
हाँ, so लॉजिक जो है वो नंबर से ही आ रही है. So if you have very few cards, you know, one out of 4 is the you know, 1 out of 4, 1 out of 52 is the probability that you will pick an ace of spades, and independently there it's out of 13 and 4 cards. So it just so happens that we have picked the problem such that the product of that 13 and 4 is 52. But when you reduce the cards to 51, that product still remains 52, but now you have this 51. So you get this factor of 52 by 51 here. Okay. It is just by design of the problem, the design of the question was such that. Aisha, you still have a question?
No, sir.
Okay, so hand is raised, so maybe you can put it down. Okay, now I'm going to talk about what we call pairwise independence. Pairwise independence. Pairwise independence. Okay. Let's consider 3 events: A1, A2, A3. 3 events. 3 events: A1, A2, and A3. So pairwise independence tells us that A1 and A2 are independent, which means the probability of A1 and A2 together is probability of A1, probability of A2. Probability of A1, A3, all possible pairs here. Probability of A2, A3 is equal to probability of A2 into probability of A3. So all possible pairs are independent. So this is called pairwise independence. This does not mean that A1, A2, A3 are independent together. Does not imply. That may be possible, but does not imply. This does not imply the independence of all events. By the way, all events can also be independent if you have probability of A1, A2, A3 to be equal to probability of A1, probability of A2, probability of A3. If you have this, then all these three events are independent of each other. But pairwise independence does not imply this. This does not imply this. Okay. We'll have some example here. And I will not show this here. Rain on day one. Rain on day one, and let's say this is the event R, and probability of R1 is equal to 1/2. I define R2 as rain on day 2, and the probability of R2 is also equal to 1/2. So, and I also define this new event, which is D, which is rain on exactly 1 day. Exactly 1 day. So, yeah, day 1 पे हो जाए या day 2 पे हो जाए, but not both. और ऐसे भी नहीं कि दोनों दिन पे ना हो. So, everyone can find the probability of D. Probability of D. What would be the probability of D? One over 2. Why? Because probability of D means that you get rain on day 1 and no rain on day 2. Plus the probability you get no rain on day 1 and rain on day 2, which turns out to be 1/2, which is 1/2. Okay. Now, what is the probability of R1 and R2 happening together? R1 and R2 happening together. Chat window. R1 and R2. Day 1 पे भी बारिश हो, day 2 पे भी बारिश हो. Rain on day 1 and rain on day 2. Rain on day 1 and rain on day 2. The probability of rain on day 1 is and probability of rain on day 2. So intuitively, if you think about it, rain on 1 day probably doesn't affect the rain on the second day. Well, maybe it does. No, but we have kept it as 1/2 times 1/2 separately. So that means it's 1/4. So you can see that R1 and R2 are pairwise independent here. What about R1 and D? Is this equal to probability of R1 into probability of D? For this, we will need to find out. What is the probability of R1 and D. The probability of R1 and D in chat window. Probability of R1 and D. Okay. You have rain on day 1 and you have rain on exactly 1 day. Okay. Which means you have rain on day 1 and no rain on day 2. Okay. Is this equal to probability of R1 into probability of D, which is 1/2 times 1/2. This is correct, which means R1 and D, they are also independent. By symmetry, R2 and D will also be independent. However, we have to be very, very careful. If I change these probabilities, from 1/2 to, let's say, 1/3, then it may not be true that R1D probability of that is the same as the product of the probability of R1 and the probability of D. Okay. We will leave that as an exercise. So when do we say that many events are independent? Independence of many events. Okay. By the way, I just recalled, we have a homework which has been uploaded on LMS, and it's about independence and conditional probability, Bayes rule, partitions. very simple questions, very simple questions. No random variables as yet. We will start random variables in the next lecture, but we will not have a homework as yet on that. We will have a homework on that later on. Okay. So independence of many events. The events A1, A2, dot dot dot, all the way up to AN, they are independent. They are independent if for any subset, ये कितने events हैं? These are n events. Okay? And if you take a subset of these events, for any subset of these events, if you take any subset of these events, let's say you take A1, A4, and A7, they should all be independent. Okay, if for any subset S of 1, 2, all the way up to n, we have probability of A1 and A2 and A3, probability of this can be written as probability of intersection of I belonging to S. So this is the set, any subset S of 1, 2, 3 up to n, I belonging to S, AI is equal to the product of I belonging to S individual probabilities of AI. This is a generic way of saying, that probability of A1, A4, A8, A9 is equal to the probability of A1, probability of A4, probability of A8, probability of A9. Yeah, this is one specific example of the above expression. Above is the generic way of saying it. ये आपको एक instance इसका हमने बताया. Okay. Now we have something which we define as conditional independence. So what is conditional independence? It is possible that two events are not independent. They are dependent on each other, but given some other event, they become independent. Okay. So two or more events, they may not be independent, but given some other event, they may become independent. Okay. So two ways of expressing this. One possibility is that probability of A and B, okay, probability of A and B, let me just erase this a little bit. If probability of A and B is not equal to probability of A into probability of B, which means that they are independent, they are not independent, which means that they are dependent. If they are not independent, then it is possible that A and B are independent given another event C. कोई एक C अब आपको दिया हो, conditional independence हो जाएगी. What that means is probability of, one way of saying that is probability of A and B given C is equal to probability of A given C and probability of B given C. Okay, everyone is okay with this definition? So basically what this is saying is that the probability of A and B happening together given C is equal to probability of A happening separately given C multiplied by the probability of B given C. Okay, so exactly the same thing as the independence, but everything is just conditioned on C. Everything is just conditioned on C. This is one way of saying that. Okay. Another way of saying the same thing is probability of A given B, if I can say that probability of A given B is equal to probability of A. Remember, if probability of A given B is equal to probability of A, then we said that A and B are independent, but we know that this is not the case. This is not the case. However, I would like to make this work, probability of A and B, I want to make it equal to probability of A. And this can work if C is given to you, if C is given to you. So two ways of saying the same thing, Similarly, or probability of B given A and C is equal to probability of B given C. So again, what we are saying is that the conditional probability of B given A is equal to the probability of B, both of them given C. Okay. Now, very important to note that conditional independence does not imply unconditional independence, the regular independence. Unconditional independence, and vice versa is also true. One does not imply the other, and vice versa. Okay. So इसकी example क्या है? इसकी example जो है ये है. So R1 again, rain on day 1. R2 is rain on day 2. Same example that we considered before, and D as rain on exactly 1 day. Rain on exactly 1 day. So this is with probability 1/2. This is with probability 1/2. Unconditionally, they are independent. Unconditionally, they are independent. Let me just write it down as R1 and R2 are independent. If D is given, think about it. अगर मैं आपको ये कह दूं कि एक ही दिन बस बारिश हो सकती है, and R1 and R2 becomes completely dependent, because if I tell you that you can only have rain on exactly 1 day, okay, and now if R1 is given, R2 cannot happen. If R2 is given, then R1 cannot happen. Okay, so given D, R1 and R2 become mutually exclusive. They become mutually exclusive, and when two things are mutually exclusive, then they are completely dependent. If one happens, the other cannot happen. If the other happens, the first one cannot happen. Okay. Now, one more example here. If E is independent of G and also independent of F, the question is E independent of F and G happening together? So we can show that that this is not true. By example, and the example is 2 dice. Throw those 2 dice. Define the event E as sum is 7, F as the event first dice is 4, and let's say G is the event. Second dice is a 3. Second dice is a 3. No, so in this example, E is in this example, only in this example, E is independent of F. E is also independent of G if F and G both occur. If F and G both occur, if the AND of F and G occurs, then what is the probability of E? Probability of E would be, answer in the chat window. If I tell you that F happens, if I tell you that G also happens, both F and G happen. If I tell you that, what is probability of E? What is probability of E? 1. And you will notice that this is different from the probability of E otherwise. Okay. So in this case, you will notice that E is not given F and G. E is not independent. If F and G occur, E is not independent of F and G occurring simultaneously. Okay. You can calculate the rest of the probabilities at home. Okay. Just one last example I want to do before we break off today. Next time I'm going to start the random variables. This example is going to be again cards. This example is going to be cards. Yeah. 3 cards selected from 52. Okay. Let SI is the event that ith card is spades, is a spade. Ith card is a spade. Okay. So which means S1 is the event that first card is a spade. S2 is the event that second card is a spade. S3 is the event that third card is a spade. Okay. So what is the probability of S1? Probability of S1 in the chat window. In the chat window, 13 out of 52. Great. Okay. So what is the probability of S2? How many people can find this out? Yes or no? How many people can find this out? Is this 13 over 52? Yes or no? Yes or no? Is this 13 over 52? Yes or no? So big fight going on between yes and no. Well, more no's now. So this is not 13 over 52. This is not 13 over 52. How do I calculate S2? How do I calculate S2? Well, in order to calculate S2, I will need to use conditioning. To find the probability of S2, say that probability of S1 and S2 is equal to the probability of S1 into probability of S2 given S1. This will be equal to 13 over 52. Now, how many people can easily find out probability of S2 given S1? Well, if given S1, that means the first card you already know it's spades. You already know it's spades. So that means you have 12 cards left out of those 51 cards. So this is very easy to find. This is very easy to find probability of S1 and S2. This is very similar to saying that in a box with red balls, what is the probability of getting 2 red balls? Both balls are red. So this is very easy to find. However, we still have not found out. We still have not found out the probability of S2. How do I find the probability of S2? Well, the probability of S2 can be found out by using the law of total probability. So you can have S1 happening or S1 not happening. If S1 happens, then the probability of S2 and the probability of S2 not happening. Probability of S2, probability of S2 not happening. So in order to find the probability of S2, this would be equal to probability of S1 happens and S2 happens plus probability of S1 does not happen and then S2 happens. So this would be equal to the probability of S2. This is partitions. These are partitions of S2. What we have done here is we divided the sample space into S1 and S1 complement. And then we said that you have your S2 guy here, and this portion here is S2 and S1, and the portion on the right is S2 and S1 complement. Okay. So this is the green portion here, this is the green portion here, and this is the blue portion here. Okay, very good. So now I can find out probability of S1 and S2, which we have done this already. By the same lines, I can find the probability of S1 complement and S2. You can easily find that out. Okay. What would be the probability of S1 complement S2? This would be equal to probability of S1 complement into probability of S2 given S1 complement. This is called the method of conditioning to find the probability. What is the probability of S1 complement? S1 complement in the chat window. S1 complement 39 over 52, somebody said that. Okay. What is the probability of S2 given S1 complement? S2 given S1 complement. The probability of S2 given S1 complement is 13 out of 51. This is great. This is great. Okay. So we have found that out. Now, if I ask you, what is the probability of S3? Now we don't have one event or two events. We have 3 parts of the random experiment. First random part, second random part, and the third random part, but you can extend the same logic and find out probability of S3. So try doing this at home, probability of S3, and also try to find the probability of S1 given S2 and S3. So what I told you is, okay, the second card and the third card, they both are spades. What is the probability that the first card was also spade? So try to find out this probability. This will be found by using the Bayes theorem. The second one will be found by using the Bayes theorem or Bayes rule. And this will be found by using a similar kind of argument by using partitions. So try to find these two at home. I have shared the notes to calculate these probabilities, but before looking at those notes, try to find these probabilities on your own. Okay. So we are about to break off. If there are any questions that I can answer at this point in time, that would be. Furqan, you have a question? Please go ahead.
Yes, sir. I have a question. In the previous example where we found the independence of ace and a spade card, can you go to that example?
Ace and spades. Yes, right here.
So you said that these two events are independent. I didn't get that how these two are independent, because if I pick the first card as ace of spade, then the second card which is spade, shouldn't that depend on the first choice which I made as ace of spade? Can you?
No. So here we are picking only one card. and A is the event that you will get an ace, B is the event that you will get a spade. The same card is ace or same card is a spade. You can get an ace of spade. So be very, very careful. We are not picking two cards here. We are picking just one card here, and A is the event that card is an ace, B is the event that card is a spade. Probability of A is 4 out of 52, probability of B is 13 out of 52. And again, this is just one card. These are not two cards. This is just one card here. Okay?
Okay, sir. Okay,
And-
I got it. Okay. Thank you.
Okay, Furqan question is answered. Bilal Jamil, you have a question, please go ahead.
जी सर ये सर टुवर्ड द एंड वो आपने प्रॉपर्टीज लिखी थी दो ना, तो उसमें सेकंड प्रॉपर्टी एक्सप्लेन करेंगे दोबारा, ये थोड़ा सा और आगे ये वाला, ये प्रोबेबिलिटी ऑफ ए गिवन बी सी, जहाँ पे सी इवेंट आता है वो वाला.
Are you talking about this past example that we third example?
कंडीशनल इंडिपेंडेंस के अंदर जो हम दो प्रॉपर्टीज लिखी थी. हाँ जी ये वाली सेकंड वाली सर रिपीट करते हैं, मेरे इंटरनेट में ड्रॉप हो गया था, मैं कट गया था बीच में से.
आप दोबारा सुन लीजिएगा कि आप YouTube पे अपलोड करेंगे, बट what we are saying here is कि if A and B are not independent, then this expression will hold. Probability of A and B will not be equal to probability of A multiplied by probability. But even though they are dependent, but they can be conditionally independent, which means that if C is given, then probability of A and B will be equal to probability of A multiplied by probability of B. Everything given C. Everything is given. This is one way of saying it. This is one way of saying it. The exactly same way of saying that. Exactly the same way of saying that is A, you are probability of A given B. Is this equal to probability of A? We know that probability of A given B is equal to probability of A when A and B are independent. But normally if this is not the case, it could be possible that given C, this relationship will be true. And when we say given C, that means given A, C or B given C. हर एक को कंडीशन कर दें C के ऊपर. तो C पे हर एक को कंडीशन करेंगे तो वो आपकी एक्सप्रेशन ट्रू होगी.
सर ये मुझे समझ नहीं आता नोटेशन में कि लेफ्ट साइड पे ये जिसको आपने सर्कल किया अभी ए गिवन बी, उसमें फिर गिवन सी है, गिवन से नहीं आना चाहिए.
नहीं, गिवन सी ये जब इस तरह डालते हैं this is probability of A, this is probability of A given B and C both. B भी अकर करता है और C भी अकर करता है.
तो ये एंड की सेंस में उस तरह से. अच्छा हाँ ठीक है.
A given B and C.
ठीक है समझ आ गया.
ठीक है ना. और इसमें से देखें फिर C जो है वो राइट साइड पे ड्रॉप हो जाता है. It means it doesn't matter whether B अकर करना हो. But the real thing is कि C must अकर. C की given condition है. Now you have a question. Please go ahead.
सर मेरा क्वेश्चन क्रिमिनल वाले क्वेश्चन में से है.
कौन से वाले में से?
क्रिमिनल गिल्टी या नॉन गिल्टी.
जी.
सर इसमें आपने क्वेश्चन स्टेटमेंट दी थी, पिक अ रैंडम पर्सन, फाइंड प्रोबेबिलिटी दैट he is found criminal characteristics in that person.
No, pick a random and you found criminal characteristics in that person. Okay. What is the probability the person is guilty? यानी आपने बंदा पिक किया, उसके अंदर वो characteristics आ गई. ठीक है.
ओके सर, आई मिस द पार्ट के आपने बोला है कि व्हाट इज द प्रोबेबिलिटी ऑफ गिल्टी, तो मैं सोच रही थी कि हमने सिर्फ वो फाइंड करनी है प्रोबेबिलिटी ऑफ फाउंड क्रिमिनल कैरेक्टरिस्टिक्स. ये कंफ्यूजन थी मुझे.
वो हमने नहीं फाइंड करनी. वो हमने अलग से फाइंड किया है, लेकिन वो फाइंड हमने एक्चुअली जो फाइंड करना था प्रोबेबिलिटी गिल्टी गिवन दैट दिस गाय हैज. Does that answer your question?
Yes sir.
So these notes by the way have already been uploaded. ये पहले से अपलोड हुए. Zarnab, you have a question, please go ahead.
Sir, how did we get the probability equal to 1 in the second last example that you did? If there were 3 events, A, F, and G.
Audio is very. Can you speak a little louder?
Yeah, can you hear me now?
it's very low. If you can speak a little bit louder.
Okay. How did you get the probability equal to 1 in the second last example that we did, in which there were 3 events, E, F, and G, and they were independent of each other?
E, F, G were independent of this example.
Yes.
Two dice, right? So, what is the probability?
Yeah.
So we have not calculated the probabilities here. You can calculate the probability of E by drawing that 2D diagram that we draw for two dice. You can calculate the probability of E. You can also calculate the probability of F. First dice is a 4. This would be 1 over 6. And then second dice is a 3. This would also be 1 over 6. This would also be 1 over 6. So in this example, what we can show is that E is independent of F. E is independent of G. You can prove that. You can prove that by this given data, by this given situation that E is equal to the sum is 7, E is that event that sum is 7. You can show that the E is independent of F and E is independent of G. Why? Because you can show that probability of E into probability of F is equal to probability of E and F together. You can actually show that. ये हमने यहाँ शो नहीं किया, लेकिन ये आप शो कर सकते हैं. इसी तरह E and G they are independent, ये भी शो कर सकते हैं. However, if F and G simultaneously occur, then probability of E becomes 1, which is different from the probability of E if F and G are not given. Okay, so that means E is not independent of F and G, although individually E was independent of F, E was independent of G. But if F and G are together occurring, then E does not remain independent. ये सारी probabilities हमने इसमें calculate नहीं की हैं यहाँ पे, but you can always do that. ये इनके लिए जो है ना वो 2D diagram बनानी पड़ेगी और हम calculate कर सकते हैं. Does that answer your question?
Yes.
Usama Iftikhar, Mohammed Usama Iftikhar, you have a question?
हाँ जी सर. सर मेरा क्वेश्चन वो जो डेक ऑफ कार्ड्स वाली जो एग्जांपल है उसी में से इंडिपेंडेंस की कि सर वो उसमें हम लोगों के जो कार्ड जो उनसे वो रिप्लेस नहीं अगर हुआ तो फिर वो किस तरह जो उनसे दो इंडिपेंडेंट इवेंट्स जो उनसे वो डिपेंडेंट हो गए हैं. सिर्फ हमने मैथमेटिकली तो हमने उसको प्रूव कर दिया, लेकिन वैसे ही मतलब सेंस नहीं बनती इसकी कि एक एस आए और या फिर वो स्पेड्स हो तो वो डिपेंडेंट हो आपस में. तो ये किस तरह ये हो रहा है?
13 spades हैं, 4 aces हैं और 13 spades हैं. ठीक है, it just so happens कि total card भी जो है आपके पास 52 है. ठीक है, so ace of spades अगर आ जाए उसकी 1/52 probability है और इन दोनों की अलग-अलग 1/4 और 1/13 है. It just so happens that this number वो cards इस तरह से distribute हुए होते हैं कि ये number जो mathematically जो है वो उसके बराबर आ गया. लेकिन जब हमने एक कार्ड फेंक दिया, उससे टोटल कार्ड्स तो 51 हो गए हैं, लेकिन एसेस अभी भी 4 रह गए हैं, स्पेड्स अभी भी 13 रह गए. ठीक है, सो नाउ यू हैव 1/4 1/13 4 out of 51 and 13 out of 51, but the total number of cards have been reduced. तो वो 13 और 4 का प्रोडक्ट 52 नहीं रहता. तो ऐसा कोई नहीं है कि इसके अंदर को बहुत डीप इंट्यूशन है. द ओनली इंट्यूशन आई वांटेड टू कन्वे वाज दैट कि एक कार्ड अगर फेंक देंगे ना 52 में से, उससे डिपेंडेंस तो आ जाती है, लेकिन द मैग्नीट्यूड ऑफ दैट डिपेंडेंस इज वेरी वेरी स्मॉल. ये इंट्यूशन हम उसमें से आपको देना चाह रहे हैं.
सही है, थैंक यू.
So folks, I need to break off. I have another meeting starting at 3:30 unfortunately. So अगर आपके कोई और क्वेश्चंस हो प्याजा पे पोस्ट करें or send us Piazza is the best, there will be multiple people looking at that and can answer your question, or you can always join my office hours whenever I am available, or you can also send me an email, set up a time to ask questions. Okay, TAs also have their office hours and tutorials. Please make sure to attend those as well. Thank you so much.